I love it when it's raining like this. Something very calming and serene about it. I don't like it when it's pissing down or blowing a gale though. Greetings, the Astro 30 here yet again, and welcome back to AEL. And I have no idea why I started to talk like that. It sounds kind of weird. Anyway, if you haven't subscribed yet and you're new to this channel, please consider going down below and doing so. That would really help me out immensely. Cheers! Today I want to look back at this simple DC speaker protector circuit that I messed around with in another video. Now, excuse me, the issue I have actually changed the capacitors in the multivibrator circuit here to 2.2 microfarad to give a slower flash rate, as you can see. But the issue I want to address is I have this wire that goes to the 1N4148 diodes cathode here, which brings, well, basically the collector of this transistor to ground, which allows the LED to remain solid. So if I connect that back to the relay driver's collector, that double clicking is this stupid wire. What I want to address is that LED pulsating like that, because I don't like it. Now I have routed a PCB for this as a power supply unit, but I haven't actually paid for it yet or anything, so I want to just make sure that I get this satisfactorily working to my own, sanity. So what I thought I might do is I could always add an extra transistor with the base of that transistor through a resistor connected to the base of the relay driver, and then its collector goes to the base of the first transistor of the multivibrator and the emitter going to ground, and that will hold the base of the multivibrator on this side down to ground, and the light will stay on solid. Yeah, that does work, but it's an extra transistor. What I thought I would do is I'd use a 555 timer instead, because the circuitry for that takes up a lot less space, on a PCB that is, than this does. And I still would have to add an extra transistor. But I can fit the timer in the same PCB real estate area as these two transistors are already. I'll just open the PCB file and I'll show you. So here's a look at my PCB file in the CAD. Down here is the multivibrator. I might bring up the 3D view so it's a little clearer. So there it is there. That's the multivibrator down there. And there's the LED for it. The timer itself will fit probably where these two resistors are and this transistor are on its own. And I'd still have enough space for an extra transistor. And I'll show the schematic of what I'm talking about with the timer in a minute. But there is quite a fair bit of extra real estate here not being used, except for routes going in on the underside there. So I can actually make it fit and make it work. I'm also in two minds of whether to use two relays, or as someone else suggested on the previous video on this, why I don't just use a DP-DT relay. Well, I can. I guess what this is going to be powering and protecting, I suppose a 5 amp relay on the contacts would be just fine. And there'll be a lot less current draw, because each of these relays draw 33 mA each, which takes it to 66. And, well, considering the Panasonic JW series relays draw around about the 40 mark, I'm saving about, 30 mA of current draw there. But I also got to remember that the 555 timer is going to draw 7 mA by itself. So, and the LED as well is going to draw some current, probably about 5 mA, something like that. But that's what I plan to do. So now I'll bring up my whiteboard and I'll show you the schematic that I'm going to be messing around with today. And there it is there. And this is basically borrowed from my BTL amplifier power supply section. It's the exact same circuit and it works fine off of that one, but I just wanted to show the schematic again for clarity. So we've got the 555 timer, the Q output or pin 3 is just driving the LED, that's it. There's nothing really spectacular about it. It's an off-stable flip-flop, so it'll be on, off. And with these values of resistors and capacitor, I get a flash rate of about 1.5 Hertz, I believe it is. So it sort of like flashes like that. Yeah, and here's that extra transistor I'm talking about, which brings ground up to pin 7, which is the discharge pin. R is a value that I'm going to choose. This is going to be kind of a bit of an experimentation. Because it's connecting to the base of the relay driver, well, this base of this transistor will probably get to 0.6 of a volt or 0.7 of a volt quicker than the relay driver one will, so the LED will remain solid, or go solid, before the relay is even engaged. It may take an extra, I don't know, half a second later before the relay actually engages. So the light will light up and then click. I mean, there's nothing wrong with that, that's perfectly fine. But if I can choose a resistor value here for R that will allow the relay to engage a little bit quicker first before the LED remains solid, well, win-win. I hope that makes sense as to what I'm doing. But what I'll do first is, ignoring this part of the circuit, is I'll just build up that part of the circuit, connect it to an LED and make sure it just flashes in the circuit as it's supposed to, and then I'll worry about configuring this part. So that shouldn't take me too long to do, and for reference I'll just indicate on the schematic of the protector that's on the bench here where that actually connects. So that's the relay driver part there, and it's going to connect to this base point, or basically that point. So this is our capacitor that's responsible for the delay turn on, and it goes off up to a resistor and diode. And this transistor over here is the DC detector diode transistor. So basically, yeah, I would connect it to this point. Now, whether that's going to play nice with the DC detector when it actually is going to bring the base of this more negative to drop out the relays, whether or not it's going to drop out the LED back to flashing or not, or cause issue. So that'll be something else to experiment with. So let me dick around off camera for a few minutes. I'll find some empty space, probably over this side of the board here, to put the 555 timer and its associated components, and we'll come back once I've got the thing flashing. Okay, about 20 minutes later, after fiddling and farting around, I got the 555 timer in and it's flashing away there. Now, for the sense of experimentation, I want to see what happens if I just use a diode, like it is here, from the driver output, or the collector of the driver, and see if that will bring pin 7 close enough to ground so it stops flashing. Because when I find a bit of wire, which is way too long, but it'll do for the purposes of demonstration, and I hook into pin 7, which is there, and I bring this to ground, it stops flashing. That's the whole entire point. So what I want to see is if we can use a diode instead, in the same sort of vein as it was in the original circuit, and yeah, save a bit of time and maybe a transistor. So let me pop in a diode, and I'll just use this wire that's here already to connect to it, and see what happens. Apparently yes, and it doesn't appear to be pulsating to my eye, nor really to the camera that I can see. If anyone can see it pulsating, let me know, but I can't. The question is, will the DC detector still cause this to start flashing and drop the relay out without causing another issue? Well, I guess what I need to do is hook up the other power supply so I can actually test that theory. Okay, so we're going to ignore this flashing LED here. In fact, I'll just disconnect the wire so it's not flashing, because we don't really need to see that one flashing, it's just too confusing. Okay, I've got the other power supply hooked up over here to ground and the DC detect input. So I'm currently at 16 volt. I might actually up that to the full supply voltage. Yeah, it's flashing. Alright, let's remove the DC potential, if I can. Yeah, although the relay engaged first and the LED was still flashing, but okay, that means I could probably maybe change the value of this 47 microfarad to a lower one, such as 33, just to make it a little bit of a faster flash rate, because I think that's a bit slow. I mean, it worked alright on the BTL amplifier, but it is kind of slow for that capacitor to start recharging before it starts flashing. So that may be a bit slow. So let me change out the capacitor to a 33 and we'll see what results we get then. But so far it looks like I don't even need to use a transistor. Win-win. Bugger, I'm going to do this powered up. Probably not a good idea. I can probably remove that wire. So I can take the capacitor out. And I'll put the positive of the 33 to pin 2 and the other side to ground. Well, that didn't seem to achieve much, did it? That's because I've removed, for some idiotic reason, I've removed ground from pin 1. Because that was not actually connected to the capacitor. There we go. That's a bit of a faster flash rate. I think that's a little more acceptable. That's actually cycling on and off at around about 1 cycle per second, so okay, remove the DC potential. Yeah. Starts flashing. Oh. Yeah, no, that's more acceptable. Yeah, it depends on whereabouts in the cycle the relay decides to engage as to whether this remains on quicker before the relay or not. However, yeah, I'm much more happier with that. And yes, the LED is out of focus, but that's on purpose. It's not pulsating. I can't see it pulsating in the camera's viewfinder. And I definitely can't see it pulsating in real life. That looks like quite a cool effect, actually. But yeah, anyway, apart from the focus trying to hunt, it's not pulsating. So, very, very good. Very, very nice. It's a sexy time. Borat, you have a lot to answer for. I bet Kazakhstan actually hates you. Anyway, back onto some serious topic of discussion here. So, this particular flasher circuit works better than the multivibrator. I mean, the reason for the choice of the 555 is because, well, you get a much more steady and stable flash rate. Plus, there's less components compared to the traditional ostable flip-flop. And, well, it doesn't seem to suffer from the same effects of bringing the cathode of that diode, which goes to pin 7, to ground via the collector of the driver transistors as much as it does on the original. And also the 555 is more stable with different and varying supply voltages, so it will still flash at the same rate of about 1.2 hertz or whatever it is, even down at 5 volts. There will be no difference in the speed of the flash compared to 12 volts. And even at 15 volts, it's not going to get any quicker. So it won't get slower the lower the voltage, and it won't get quicker the higher the voltage, is what I'm trying to come across to you here. So I'm actually happy with how that's come out, and I think I'm going to go with that as a design change. I'm still debating using a double pole, double throw relay, or DBDT, in place of these ones. So I've only got one connected to the circuit just to test. I don't need to have both. But currently, according to my power supply, with one relay, the 555 timer and the LED illuminated, we're only drawing about 43 mA. So the original circuit was drawing with two relays about 70. So, and I bet if I remove the LED out of circuit, because it's a more high intensity LED, it's a 600 millicandela. Well, there's 10 mA right there. So if I put the original green one in instead, well, it's about the same. There's no difference in current, so I'll just switch back to the red LED. The same amount of current, 10 mA. So it doesn't seem to matter a difference, the LED choice. It's still going to be drawing about half of its maximum current that you can out of those LEDs, which is, well, with these green ones, 20 mA max. The higher intensity, or the 600 millicandela, is about 30 mA, I believe. I'll have to relook up the specs of that. I've got the bag somewhere. So very, very good. I'm happy, and there's not much more I can really give to you on this video, except to just, well, redraw or just show you the changes on the whiteboard as to this particular circuit. So there it is, drawn up there. We've got now in place of that transistor I had there originally a 4148 signal diode, and the cathode then goes to the collector of the relay driver. That's what that says. I ran out of space to write the R. Oops. And so when that starts to bring ground up to switch the relay on, it'll come and this diode will conduct, which will bring pin 7, the discharge pin, through this diode, through the collector of the relay driver to ground, and that'll stop the thing from flashing. And I forgot to update this piece here. Please excuse me. As bad as that looks, it's supposed to be 33. Yeah. Now, I might plug into a 555 timer, because I can never remember the actual calculations that you do between the two resistors plus the capacitor to get the flash rate. But I'll plug it into a online calculator from DigiKey. That one seems to be good enough, just so we can see what it is actually cycling at. I could measure it with an oscilloscope, but I can't bother setting that up. Another reason I'm using the 555 timer is because I like them. So that's the calculator I'm talking about, and there's the formula I can never remember of how to calculate the time. Anyway, plugging in those values for R1, which is the resistor that goes to pin 7, R2, which is the resistor that goes between pin 7 and pin 6, and C1, which is the capacitor that goes from pin 2 connected to pin 6 to ground, there's our times and our frequency. So time high is 525 milliseconds on, time low is 503 milliseconds off. Almost the same, and the frequency is roughly what I said it was going to be, about 1 Hertz. I did say about 1.2 Hertz, I wasn't far off. So it's just using the 555 timer calculator on digikey.com. So that's been sitting there now for a good, I think about 10 minutes now, with DC on its input, and nothing has smoked or gone off with a bang, so everything is still functioning fine. So I can now disconnect the DC fault, and there we go. Perfect. Alright, so that's going to do it for this video, and that's the choice I'm going to go with. It'll save 2 transistors, so in the end we'll only have 1, 2, what does this one do? Oh, that's part of the mighty vibrator. 3, 4. That's it, just 4 transistors and 1 IC, as opposed to 6 transistors, and the 555 timer circuit can live up where the old multi-vibrator was, up here. I'm just going to have to redraw the schematic once I've decided about the relays. So yeah, watch this space. It will be in an upcoming video as to this particular PCB module. And there's the entire PCB routing on the screen in the CAD file. So you can see it's pretty busy, but these are the main filter caps up here and bridge rectifier. And then, yeah, as I say, the minor vibrator or the 555 timer can live down here, and I'll be saving, well, I reckon at least 2 extra resistors, maybe 3. So, as well as the 2 transistors. So that's where I'm going to go with that, and yeah, I will keep you updated in the future. Oh, the other change I did make was these input resistors that go to the capacitor over here, which detects the DC. I've changed them from 10k 1 watt devices to 47k 1 watt devices, because I found when I connected a 1 hertz source from the signal generator to the input and then cranked the amplitude of the oscillator up, so we're up around about probably about 2.5 volt, 3 volt peak to peak, well, it tripped the circuit and disconnected the relays. So that's not going to be very appropriate, so I decided to up the resistance just to combat that. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.